For this activity, you will have to cut the paper I provided and place it in a bag. I asked my husband to help me to do at least 2 trials. Um, if you read the problems here, they're asking you to do it as a class, but obviously we don't have that many people. So the more people you want to ask to do these, the better. Okay, the better results you're gonna get. So these are my results right here. I did the trials. Please don't copy my numbers. If you don't do these exercises, that's probably the reason why you're struggling, because you're not even trying. And let me tell you that next year, if you're placed in statistics, it's going to be like this, because stats is it's really heavy in word problems. Okay, so there are some things that are easier than others, I guess, but if you struggle with word problems, you cannot run away from them in statistics. Okay, so try, please try. Some of you are not trying at all and are cheating, in fact. So prompts for those of you who try and are always on top of it. Please continue like that. It will pay off. So I did this, okay, and this is my husband's. He helped me out. So what I'm gonna do right now is that I don't want to create a dot plot by hand if I have GeoGebra. Okay. So I'm gonna just put these numbers in there. I'm gonna show you how to do that. So you need here, let's see, no. You need this, and then go here, and then go to the spreadsheet, and I can get rid of this and get rid of this, and then I can go here to my numbers. So my first, and we're gonna do the proportions of the slips. By the way, proportions, how do you find a proportion? So the way you find a proportion is that here you have in each trial you have 10 trials, right? Like you do these 10 times. So I got, out of those 8 trials, I got 8 slips with a pass. And then to find the proportion, I'm going to divide 8 divided by 10, 9 divided by 10, 6 divided by 10. So a proportion is simply a ratio, okay, of how many numbers you're looking for divided by the total. So that's how I found it. Oh, where was I? Oh yeah, so it's going to be 0.80, 90, 0.60. So here I'm going to say 0.80, 0.90, 0.60, 0.40, and then 0.90 again. Oh, sorry. And then I'm going to do my husband's 0.80, 0.50, 0.70, 0.70, and then finally 0.50, and then 0.10. Okay, if obviously I were to get all of you, I would have a long here list, but if you can get another person, another 2 people, it's gonna be even better, and you're gonna see why. So I'm gonna highlight this, and then I'm gonna come here, I'm gonna click on one variable analysis, and this is gonna give me a histogram, but I don't want a histogram, I want a dot plot. So I just click it there, and that's it. You can see your dot plot there. If you want to look at the grid of this, I would just click show grid, and then I will be able to see my grid here. I want to copy and paste this screen, so there is a function that you can use. It's called snipping tool. So you just click on that, click new, and then you can just copy and paste. So this will become a picture. You come here, and then I will copy these into my I already had one, but I wanted to show you how to do it. So there it is. I copy these. And that's my dot plot. Okay, it says create a dot plot based on the trials from the class that shows the proportion of slips drawn that are marked pass. So that's mine. Obviously, you can see, hopefully by now, and you can play with this here by changing the to a histogram. You can see here that's kind of, you know, skewed in this direction, right? So in this case, it's skewed right. So mine looks like this because I don't have a lot of points, but if you have a lot of points, it might look different. You can create a bar chart, you can create whatever, like all those there. So mine doesn't look good, okay? Because I don't have a lot of numbers, but like I said, you can try as much as you want to, but this is enough, I think, to make a comparison to other ones. So let's go back. So it says from the class dot plot. Obviously, we don't have a class dot plot, so I will just use this one. Estimate the proportion of slips marked pass in the bag. Explain your reasoning. So first of all, the proportion of slips will be what's the average of this, right? What will be the average of all of them? So I can take a look at the mean, okay? I can take a look at the mean. What's the average, right? What's the proportion? If we add all them up and divide by 10, what will be my average, the proportion? So that will be 0.62. Now, if we think about what the problem is asking us, the problem is asking us to look at what will be a pass or fail, right? So I would say take an estimate of what will be a good percentage for us to say that it's a pass, okay? I would say that it will be probably around 80%, okay? That it will be 80%. So I have here some questions that I would like to go over with you, okay? And before we answer this question, so from the dot, estimate the proportion, we already said that, right? It's 0.62. And I used just a tool in GeoGebra. But now let's just do a synthesis of this. So if we have another graph, okay? And let me show you how it looks. So this is the graph that, let's say, compared to some other group, okay? Some other group, or even with the class itself. So as you can see there, okay, as you can clearly see here, there is the average, okay, the mean, it's around 0.7. Mine was 0.2, and if we go back here, mine looks like this. And hopefully by now, you start to realize why it looks like this. How many trials I did? I did a set of 10. But here, look at all those dots. That belongs to a lot of trials, right? So the more trials you do, the better this is going to look. That's why it's important to have enough data, okay? And how can you apply this to real life? Well, when you watch the news and you hear that this candidate is doing better than this candidate because the poll says that, you know, they say that 55% of Americans are on favor of this, and then the rest of Americans are not, I would be skeptical of those statistics because you don't know what's the sample, okay? You don't know what was the population. Okay, did they take a sample? Did they take a population of just 100 people instead of 1,000 people? Okay, so you can see how here my data will vary. Okay, this is really spread out because it's not enough. But this one right here, it seems reasonable, right? Like it seems reasonable. So it says here, should the other group be more or less confident that their estimate is close to the actual population proportion that we should be about our estimate? Mine, I will be skeptical of mine, okay? Because the data is really spread out. And if your brains start to, make those connections, hopefully by now you understand that if you have a standard deviation that's really big, that's what's going to happen. Your data is going to be spread out. But if your standard deviation is small, then you're going to have a tall, a thin curve. Okay, so that's what this means. So we're going to compare the standard deviation of this graph to the standard deviation of mine. Okay, and then that's how we're going to determine if the margin of error actually will give me a reliable response or not. Okay, so the next question is, how would the value of the standard deviation of the sample proportion affect your confidence in the answer? So we just say that, right? We just said it. The greater the standard deviation will tell us the estimate has a wider range of possibilities because obviously it's more spread out. So I will be less confident because I know that there will be way more possibilities, especially if the data was collected just from a very small sample. So all these things hopefully now start to click. What interval could you be approximately 95 confident contains the population proportion for the class data? Well, remember that 95% means, in the case of the standard deviation, 2 above and below the mean. So in this case, the margin of error is twice as much as the standard deviation. So we simply need the mean minus twice the standard deviation, which is the margin of error. Sorry, this thing cut me off. Anyways, so this is for the first question. That's how we find it. And then the next one is, how is this interval related to the margin of error and the standard deviation? I just said it. The margin of error is twice the standard deviation. Last question, it says the standard deviation from the other group in the dot plot is approximately 0.202. So I'm talking about this one, okay? And then if we want to be 95% confident of the population proportion using the sample proportion, what margin of error should I use for our class data, for the group's data? Again, you just have to create, you just have to look up here and then look at what they tell you the standard deviation is and then come up with your conclusion. However, if I want to use mine, okay, I can simply look up here and using my probability calculator, I can look up here what it says. So it says here that my mu is 0.62 and my standard deviation is 0.253. And it makes sense that it's going to be larger than the other one because mine is more spread out. So I know that when I hit that 95%, okay, I can stop. So I'm almost there, I'm almost there, I'm almost there. Almost there. So let's see. I think that will be close enough. And then if I move it here, there we go. I think that will be close enough. So 0.11 and then 1.11 will be in my case for this one, okay? But in general, if I want to know what will be the margin of error, then the margin of error will be just that 95% confidence, okay? Which is 2 times the standard deviation, and you need the mean.